Hello, this is Jonathan Trinh, and I am here to present the demonstration for my Smart Vase IoT system project. So the Smart Vase, if I go to the circuit board and focus it, you can see I have a temperature and humidity sensor. I have a photoresistor and an ultrasonic sensor here. Should anything be wrong, say the water levels are low, or if there isn't enough light, then the system will raise a flag and tweet out for the user to make an adjustment. So if we go to Twitter here, you can see that a few hours ago when I was running this project, the Twitter bot made a request for more light, more humidity, and etc. So while all the sensors are running and while there's data being collected, I am sending it to Firebase here. I'm using the real-time database, so if I click into it, you can see, let me just collapse the data. I've been running it for 4 days for my test scenario, so there is a lot of data at this point. You can see the distance data, which is the water levels of the vase, the humidity and temperature of the ambient room for the flower, and the light levels. So if we go into the humidity and the temperature aspect for the data, you can see it does print out the humidity and the temperature of the ambient room surrounding the vase. So for my test scenario, if I zoom out to show both flowers, for the test scenario, I essentially ran one vase with the smart system to monitor the rows and another vase with no smart system and no monitoring. So with the smart system, I essentially ran both the smart vase and the dumb vase for 4 days. And so as you can see, after the 4 days, the smart vase on the left has a rose that looks healthier, while the dumb vase on the right has a rose that looks like it is closer to its demise, to say the least. The program, I set the program to basically only receive or only to collect hourly averages, but for the sake of this demo video, I sped it up. You can see the sensor is settling for the distance. The distance has been given at 6.5 centimeters, or roughly 2.5, 3 inches, which is accurate here. The ultrasonic sensor to the water is at a distance of roughly 2.5 inches to 3 inches. And then if we go back here, it says that the water level is good at 6.7 centimeters. It gives the humidity, the temperature, and the photoresistor. Then if we go back to here, in a second, you should be able to see the data update as it gets pushed out. See, so the humidity and the temperature, along with the light, is updating. The distance is updating along with what is being shown in the terminal. Or to force the program to flag a warning to be sent out to Twitter, just to kind of force the case for the demo, I can maybe set the conditional for the humidity to a very high value, which wasn't the case for the test scenario because it wasn't the threshold but for the rows. But if I was to set the bound and force the flag just to demonstrate the Twitter aspect of the flags and the warnings, and then if I run the program, it calculates the distance, and now it's grabbing average values for the other sensors. So you can see, since I forced the threshold, it says the humidity is too low at 57%. And then if I come back to Twitter here, it shows that there is low humidity at 57% and that it is the first iteration. It also shows, I didn't show earlier, but since we're running it at quick intervals for the demo, it is showing that it needs more light, because if I step back, I am taking this video at my desk, so obviously there isn't enough light for the roses. And that is the Smart Vase project.